In this video, I will be demonstrating how to use the algebraic method to balance a chemical reaction. Here on the board we have a combustion reaction, and the first step in algebraic balancing is to assign what I call dummy coefficients for each component in your reaction. So once you've assigned those, the next step is to develop the equations you'll use to actually solve using the algebraic method. And for that, you have to use each element. So I'll have an equation for carbon, one for hydrogen, and one for oxygen. Once we do that, we use the facts of the stoichiometry and the molecular formulas to develop the equations. So however many of these I have, that's controlled by A, and 3 times A is the number of carbons I'll have on the reactant side. On the product side, it's 1 times C. Those values have to be equal. In the same way, I can develop the equations for hydrogen and for oxygen. Now at this point you haven't done any work that involved making decisions. The next step then is the thinking step. You'll have to look at the equations you have and figure out if it's possible to get values for all of your dummy coefficients by picking a value for one. If you find that this works, then you can proceed to the next step. So in this case, I observe that if I pick a value for A, that will determine the value for C. It'll also determine the value for C. And knowing the values for C and D will allow me to get a value for B. So I am going to let A be equal to 1. If A equals 1, then from the carbon equation, 3 times 1 is 3. So C will equal 3. If A is 1, 8 times 1 is 8, and 8 equals 2D. So 8 divided by 2 tells me that D will equal 4. Because I have values for C and D, I can determine a value for B using the oxygen equation. And for that I can simply substitute in. So I have that 2B equals 6 plus 4, which is 10. That means then that B equals 5. And so at this point, I can go back in and substitute for the dummy coefficients the actual completely balanced values. A equals 1, B equals 5, C equals 3, and D equals 4. And if I want to verify, that's a simple check step. I have to make sure that my carbons, hydrogens, and oxygens are balanced. On the reactant side, I have 3 carbons, and 3 times 1 gives me 3 carbons. So that checks out okay. For the hydrogens, I have 8 here, and 4 times 2 gives me 8. So hydrogen checks out. 5 times 2 gives me 10 oxygens as reactants. 3 times 2 plus 4, this is 6 and 4, that gives me 10 oxygens as products, and so everything checks out.